All right, we got a few examples to go over of a different type of problem that we're going to be doing here. And if you look at the first example, it gives you the cosine of an angle. It doesn't tell you the angle. It gives you its cosine. And it gives you one other piece of information. And here it tells you the angle is in quadrant 3. And our instructions here are to find all 6 trig values. So in addition to the cosine, we also want to find the sine, the tangent, the secant, the cosecant, and the cotangent. So the way you're going to do this is you're going to take some stuff we've learned about the unit circle and all that, and you're going to combine it with like the very first thing you ever learned about trigonometry and sine, cosine, and tangent, which was probably some variation of this little memory device, SOHCAHTOA. So the idea is to find sine, cosine, and tangent of an angle, you can always make a right triangle. And the sine of the angle would be equal to the opposite side of the triangle over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what we're going to do, we're going to take this cosine of theta equals negative 5 over 13. We're going to ignore the negative right now. And we're going to make a right triangle. That's a terrible right triangle, but you'll get the point here. And I'm going to mark my angle that I'm working with. Again, I don't know the measure of this angle. I just know its cosine is going to give me a 5 over 13. So cosine is adjacent over hypotenuse. That means the 5 is my adjacent side, the side that is touching the angle. And the 13 is the hypotenuse, the longest side of the triangle. So if I can find the opposite side, then I'm going to be able to find my sine, my cosecant, my cotangent, all that stuff. So I need to find that third side, that missing side. So what I'm going to do is Pythagorean theorem. A squared plus b squared equals c squared. I know 13 is my c because it's the hypotenuse. So 5 will be my a. So I'll have 5 squared plus my side I'm looking for, b squared, equals 13 squared. I'll work this out. And I will find that b is equal to 12. And you may have like Pythagorean triples memorized if you ever had a chance to do that. That'd be a helpful thing here too. But this missing side is 12. And 12 is going to be the opposite side. The 5 is going to be the adjacent side, and the 13 would be the hypotenuse. So now I know that my 6 trig identities will all involve some combination of those 3 numbers, the 5, the 12, and the 13. But I have to take into consideration this other piece of information I have. The angle that we are dealing with here is in the 3rd quadrant. So what that means, in the 3rd quadrant, x and y are both negative. If x and y are both negative, that means sine and cosine are both negative. So let's go ahead and start getting these down. I know my cosine already. Adjacent over hypotenuse is negative 5 over 13. My sine is going to be opposite over hypotenuse. So that's going to be the 12 over the 13. It will also be negative because I'm in the 3rd quadrant. And sine is my y value. Y is negative in the 3rd quadrant. Tangent, there's 2 ways to find tangent. It's opposite over adjacent. It's also sine over cosine. And here, if our sine and our cosine are both negative, when we find tangent, those negatives cancel out. Tangent ends up being positive. So I'm going to go opposite over adjacent, 12 over 5, and it's going to be positive. Now, the other 3 are super easy because all I have to do is flip the original 3. So cosecant, I just take my negative 12 over 13, make it negative 13 over 12. Secant, negative 5 over 13 becomes negative 13 over 5. And cotangent, 12 over 5 becomes 5 over 12. Notice that the cosecant, secant, and cotangent have the same sign as their reciprocals. So if sine is negative, cosecant is negative, and so forth. All right, next example. It says tangent of theta is 4 over 3. Let me switch up the color here. So 4 over 3. So I'm going to go ahead and make a right triangle again. And here's my angle. This is 4 and 3. And I labeled those two because tangent is opposite over adjacent. So 4 is the opposite side, the side that's across from the angle. 3 is the adjacent side. I need to find my hypotenuse. So again, I can do a squared plus b squared equals c squared. And I will find that my hypotenuse is equal to 5. And now I have all three, so I can start to piece this together. The thing I have to look at this time is it says my sine, the sine of this angle, is less than 0. The sine is negative. And so, again, if we think about the unit circle, that's going to put us on the bottom in one of these two quadrants. So my angle has to be in one of these two quadrants because the sine is negative. But the quadrant doesn't even really matter. Here's what matters. Let's go ahead and get our sine down. Our sine of this angle is opposite over hypotenuse, so it's going to be 4 over 5, and we know that it's less than 0, so it has to be negative. My tangent, I'm going to skip cosine for a second. My tangent, we already know that's given to us. It's 4 over 3. So my cosine, depending on which quadrant I'm in, it could be positive or negative. So to figure this out, I'm going to look at what I already know. I know my sine is negative. My tangent is positive. The only way I'm going to get a positive tangent if I have a negative sine is if the cosine is also negative, because negative over negative would give me a positive. So my cosine will be negative. It will be adjacent over hypotenuse, so 3 over 5. And then to do my other 3 again, I just flip and keep the signs exactly the same. So cosecant is negative, secant negative, and cotangent will be positive. One quick thing, make sure you remember that cosecant goes with sine and secant goes with cosine, because that is a really easy thing to mix up. So it's really going back to what you learned about this in geometry when you were first introduced to it with the right triangles. And all we're throwing in is whether or not it's going to be positive or negative based on where it ends up on the unit circle. One more example, and I guess this one also goes a little beyond what you probably did in geometry with this, because we're starting with cosecant. So our cosecant is negative 25 over 7. So let's think of SOHCAHTOA again. SOHCAHTOA does not have a cosecant in it. It's just sine, cosine, and tangent. So here's what we're going to do. We know if the cosecant is negative 25 over 7, the sine, we would just flip that. So our sine is going to be negative 7 over 25. So now we've got something we can work with. So now I'm going to draw my right triangle. This will be my angle. Sine is opposite over hypotenuse. So 7 is the opposite, 25 is the hypotenuse. And then I can find the adjacent side using a Pythagorean theorem. So it really doesn't matter which of your legs is A and which is B, as long as the hypotenuse is C. At any rate, we'll get a squared plus 49 equals 625. A squared is equal to 576. And if you take the square root of that, you'll find that A is equal to 24. So my third side here is 24. So 7 is the opposite, 25 is the hypotenuse, and my adjacent side is 24. So now I have my 3 numbers. I have this other piece of information here. I know the cosine is positive. It is greater than 0. So let's go ahead and get that down. Cosine of theta is adjacent over hypotenuse, so 24 over 25, and it has to be positive. We're told that it's positive. And so secant, also positive. We're just going to flip it. So now for tangent, if I have a negative sine and a positive cosine, I have one of each. A negative divided by a positive is going to give me a negative. So my tangent will have to be negative. Tangent is opposite over adjacent, so 7 over 24. And then cotangent, it also has to be negative, and we flip it. So that would be my recommendation. If you get a secant or a cosecant or a cotangent, flip it to find your sine, your cosine, or your tangent, then make the triangle, then start filling out everything else. So that is how you can find all 6 trig values, just using a little bit of information and one of the 6 values, having that already. So there you go.